Welcome to another episode of libGDX-Graph devlog. I've been pretty busy with life the last couple of weeks. I also participated in a libGDX game jam, and I've submitted this, not really a game, a demo, graphical demo that I'll be showing in this episode. I'll show it twice. First time without any interruptions. It's very short. It's like less than a minute, I think. And then second time I'll show it and just pause it from time to time and highlight what you're seeing and explain what you're seeing. Okay, so let's go with this. This is going to be first the video of the demo without any interruptions. Okay, now the second time when I'll explain what you're seeing. So first of all, as a couple disclaimers, no shader was written at all during the creation of this demo, and all the models, the 3D assets were from the cgtrader.com. So first scene here, it's a spaceship or space station docking bay or whatever, where you have this force field on one of the walls of the space station, and we have spaceship approaching here. So the way this is, as you can see, it's a Voronoi distance field, and I'm applying very heavy alpha here. So normally it's very blue, but because there's a heavy alpha here, I think it's between 0.1 to 0.2 alpha, depending on the Voronoi distance. You're seeing this kind of shimmer. And the cool thing for this shader is that when the spaceship approaches, the pixels of this force field are detecting that there's proximity of another model, and then intensifies the alpha to increases it from whatever value it has all the way up to 1, whenever it's like really close to the geometry of scene. So the way it's working is basically first all the non-transparent things are being drawn in the scene, and then when this force field is being drawn, it takes the depth of the scene at the time when it is being drawn. For example, for this pixel where I'm pointing at here, it takes the pixel and checks the position of the pixel and what is the distance from the position of the model that is being drawn in this scene at the same pixel on the screen. And if it's very close together, if they are close together, it basically detects that there is a proximity, and based on this, it increases the alpha value of this force field. So that's how you get this effect. It's pretty much the same with the spaceship force field here, as you can see on the edges here, where it's touching the floor here. The only thing here is added here is that normally the model of this force field for the spaceship is this kind of oval, which is like a deformed sphere. But as you can see, it's the the geometry raises from the bottom to the top, but it doesn't like raise with a scene. There's a cutoff which is very irregular, and the way I do it is I basically apply a noise here on it, and based on this I decide where the cutoff point for this force field is. Additional effect here, as you can see, is that the edge of the cutoff is much higher opacity. That's something that I also do within the shader, and also it fades from this edge into the model of the sphere. So it's like you have very distinct edge to this raising force field. Another thing in this shader for this specific for this force field for the spaceship is that, as you can see in the middle of the model, the alpha is close to 0. However, the closer you get to the edge, thanks to the Fresnel effect, which basically detects the normal of the object. In this case, this deformed sphere is pointing, you can imagine, in this direction, like in this point, in this direction. However, the view or the camera normal, so the camera, direction, is pointing from our eye all the way into this point. As you can imagine, it's from where you're sitting to this point. Therefore, there is a big, the angle between these two is pretty big, and based on this angle, you can, for example, in this case, I'm increasing the opacity. You can do many other effects with this, which is basically called Fresnel effect. So as you can see on the edge of the sphere, the alpha of the force field is very, very high. So it's like pretty much opaque. But the closer you get to the center of the sphere, so where the normals are pointing pretty much the same direction as the view direction, so the camera direction, you can see that the alpha is being reduced all the way to almost to 0. Only at the edges you have the additional opacity added. Another thing is that the color of this force field is basically a noise texture, as you can see here, especially visible in this part of the image of the video. And the same way, like the raising of the force field here, the same, not the same way, but the same idea is used here for this disappearing effect of the model. So whenever I draw any pixel of this spaceship model, I check. I basically get a noise, 3D noise value of this pixel, and if it's above a threshold, so let's say we start with a threshold of 1, which means that it's never going to be above it, so we just render it. But the lower it gets, the more pixels of this will disappear, and basically the holes will be increasing and merging into one big hole, and finally the model will disappear. Additional effect here, once again, you have this edge, the same way we had with the edge on this force field, this spaceship force field. The same way we have an edge detection here, and so basically when I detect that I'm getting close to the cutoff, I add some red tint, and finally at the very edge of the cutoff, I have this red, fully red tinted model. So this is the disappearing part of this model, and in here we have Gaussian blur and fading to black. So this is stuff done with post-processors. So in this scene, the couple of interesting things here. So right off the bat, we see here water. And as you can see, the water is moving. There's waves, or something that appears as waves. So this is like the simplest possible water you can make using shaders. It's not like fully realistic, it's stylized. So the way this is done, the cool thing that it is in Java, that the waves are, as you can see, they are creating geometry. But in Java, this is basically a plane, or part of a plane, like a rectangle that is put here, and the vertices of the plane are not modified in Java. Instead, this texelated plane, so like the plane with this like kind of triangles, like as you can see here, that used for the ground, the same way they are used for the water. They are being modified in the vertex shader using, I think I'm using Voronoi distance for this. So once again, the same way the force field for the space station was used, it detects the proximity of the terrain here. So it checks the depth of the water basically at this point. And if it's close enough, it adds this white tint to it to basically indicate that it's like a foam when the water hits the shore. So this is not done in Java. This is done also in the shader, the proximity detection. So if you suddenly start dropping stuff in the game into the water, the same kind of foam is going to appear around anything you add to this water without you having to do anything programmatically at all. So as you can see, also the color for the water is using the Voronoi distance. You can see these Voronoi shapes here. They imitate water. This is one of the way you can do water, as I said, kind of stylized. It's really quick and not much work, and I think it's reasonably pleasing. So another effect here that you can recognize from if you watched the previous episodes, you'll be able to see the hologram shader. This is something that you can look, I think, like 2 or 3 episodes back. You will see this shader, how it's done, and explain. I probably should have modified it so that the distortion are a bit smaller, but I just didn't have time. Just took it without modifying anything and just applied it to this model. So in here you can see another post-processing effect, which is the bloom effect, which basically detects anything bright in the scene above some cutoff point, and taking if the color is above this threshold of the luminosity, it blurs it out bleeds into other models. So if you wait a bit longer, okay, so you can see that the color of the sky is bleeding into the model of this reptilian worker. The same way you can see even though the geometry of the sphere here ends the edges over here, you can see the white color of the sphere bleeding into the model here. And so this is the bloom effect, which is also using the post-processing that I've explained, I think, on the 3rd episode, I think. The same applies here for the lighted part of the cloud. You have this bloom effect applied here as well. Okay, so over the next couple of episodes, I probably will dig into these specific effects to show how you can do them yourself, especially the spaceship, the raising shield on the starship. I think is an interesting one, and uses a couple pretty cool techniques, I think, that are useful. The same for disappearing of the spaceship. I think these kind of transitions effects that require very little work if you're using the graph, and from programmatical point is just you just define like one variable for your model, and you modify it over time, and you can have like disappearing or reappearing things, including the edge around the holes of the disappearing effect. Yeah, so I hope you find this useful. If so, please like the video. Please also subscribe to the channel to be notified of any new videos. Thank you for watching. Bye.